Week 13, lesson 4. All right, so we're going to be solving trig equations in this lesson, which may mean having to use some of the formulas that you've used in the past. It may mean using the quadratic formula, which you've used in the past. So you're kind of taking skills that you've learned prior and putting them all together along with trig. Okay, now a couple things to consider. Sometimes you will get an extraneous solution. I promise you one of my examples will have it, so you'll kind of see what happens there. All right, so you may want to just sort of think about your answers and if they make sense. Okay, so let's come over here and let's do example number 1. All right, the first thing I want you to notice is the domain. Okay, so here we're looking for answers between 0 and 2 pi. Notice that the 0 is included, but the 2 pi is not. All right, this also indicates that your answer needs to be in radians. Okay, sometimes your answers will be in radians. Sometimes they'll be in degrees. Sometimes you are just going to have to know to look to decide whether it's in radians or degrees. It may not be like distinctly stated. Okay, so now that I've said that, let's do this problem. So in this case, I'm going to divide both sides by 4. And then I'm going to take the square root, right? Because I don't want sine squared of x. I just want sine of x. So plus or minus the square root. That does simplify to plus or minus 1/2. Now, on your unit circle, if you're looking and looking and looking, sine is positive here and here. And then sine is negative here and here. So this problem actually does have 4 answers. It's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, again, break out that unit circle. Make sure that you know it. Okay, so for the example, again, the domain is in radians. Okay, so my answer is going to be in radians. It's in 1 rotation about the circle. This is quadratic because of the square. All right, if we're lucky, it will factor, and if not, then we'll have to do the quadratic formula. Okay, now this one does factor nicely. It is 2 cosine x minus 1 times cosine x minus 2. If that's not making sense, or if you don't know where I got that, again, please ask in Zoom or ask in person, okay? Now, when I set the first one equal to 0, I get the cosine of x equals 1/2. When I set the second one equal to 0, I get the cosine of x equals 2. This one, let me highlight it, is extraneous. There aren't any cosine values on your unit circle that are greater than 1. Okay, so again, you did do this problem correctly. It's just an extraneous solution. Okay, so let's solve the other part of that, which is right over here, where the cosine is 1/2. And the cosine is 1/2 in the first quadrant and in the fourth quadrant. So the first quadrant answer is going to be pi over 3, and the fourth quadrant answer is going to be 5 pi over 3. Okay, so for this example, again, the domain is in radians. It's in 1 rotation about the circle. Now, take a look at this one, all right, because this one's kind of a big deal. The first thing that I'm noticing, all right, that I'm hoping you're noticing too, is that there are 2 different angles. This and this are the same angle, but this is something completely different. Okay, and then the second thing that I'm noticing is that some of these are in terms of sine, and some are in terms of cosine. So there's kind of a lot of things to deal with here. So let me start making some substitutions, okay? I am going to substitute in for this, right? There's 3 different choices. You can go back in your notes and look at them. But the choice that I'm making is to make this cosine squared of x minus sine squared of x. That's the substitution that I made. Okay, and the reason I picked that one is so that this will cancel with this. All right, now to solve what's left, in fact, let me rewrite it and then I'll solve it. So this is what I have left. This is quadratic, and I can solve this by factoring. All right, and then I'm going to set each of those equal to 0. So I'm going to have the cosine of x equals 0, and I'm also going to have the cosine of x equals 1. Okay, now this is when I have to go on my unit circle and figure out where does this happen. Okay, so the cosine of x equals 0 at the top of the circle and at the bottom of the circle. And the cosine of x equals 1 at the far right-hand side, right here. Now, 0 is included, but 2 pi is not. So the answer here is going to be 0, 3 separate answers. Be really careful on what's included and what's not, because if you put 2 pi there instead of 0, that part is wrong. Okay, so I think I'm on the last example. Now notice this one, okay? The domain. Not only is it in degrees, but it's from negative 180 degrees to positive 180 degrees, which means if I sort of draw this out a little bit, right, if here's the circle, I'm starting here and I'm going around this way and ending here again. So yes, it is still one rotation about the circle, but these answers down here are going to be from 0 to negative 180. Okay, second thing to notice. I've got 3 different trig functions going on here. I've got cosine, I've got secant, I've got tangent. That's a lot to take in. So let me see if I can rewrite this in a different way. So I know that secant is the reciprocal of cosine. And I know that tangent is actually sine over cosine. All right, so what I'm going to do to make this look just a little bit nicer is I am going to, excuse me, fraction bust. Okay, I'm going to multiply this entire equation through by the cosine of theta. So I have 4 cosine squared theta minus 3 equals 2 sine theta. Okay, so this looks a little better, but I still don't have everything in terms of one trig function. So I'm going to make another substitution right here. Using the big kahuna and solving it for the cosine squared of theta, I have 1 minus sine squared of theta. If that's not making sense, please ask in Zoom or in person. Let me scoot this up a little. Okay, so distributing, combining like terms, and moving everything to the right-hand side. Okay, and I'm assuming you can distribute and combine like terms and move everything on your own without me showing every single step. But you should end up with 4 sine squared theta plus 2 sine theta minus 1. Oh wait, I already have the equal 0. Sorry about those last 2 things. Okay, so now if this factors, great. But if not, we're going to have to use the quadratic formula. And I'm sure you're looking and looking and looking, but it does not factor. So here we go. We're going to do the quadratic formula. So the sine of the angle, right, is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And then if you simplify all that stuff using your calculator, you'll get sine of theta equals 0.309. You'll also get that the sine of theta equals negative 0.809. Okay, so this is going to have to be done with your calculator. Now, just remember, you are in one rotation about the circle, and the ones that are in the third and the fourth quadrant have to be named negatively. All right, so you're going to break out your calculator, make sure that it is in degrees, and when you do this problem, you should get 18 degrees, which is great and fine and dandy, but it's only one of the positive answers. There are 2. So to get the one that's in this quadrant, that 18 is actually the reference angle. So you get 18 and 162. Now, when you do this one in your calculator, you'll get negative 54 degrees, which is fine. It's within the range of that domain. But the other answer, because sine is negative in the third and in the fourth, so the other, this is going to be the reference angle. So the other one that you're going to find is negative 126 degrees. Again, if it doesn't make sense, ask in Zoom or in person.